So job tracker is the master daemon and it is responsible for scheduling and monitoring. So it will schedule the jobs and as well as it will only monitor the jobs. Now how it will schedule the jobs? It will schedule the jobs on the task trackers only, right? Right? So it will schedule and monitor the jobs from the task trackers. These are task trackers. So the task trackers in turn will run mapper task and reducer task to process the code. In turn, they will run map task, reduce task to complete the job. By default, 2 maps and 2 reduce, right? So as per the requirement, first of all, the maps will be used and then the reduce task will be running. Map tasks and reduce tasks. Map task and reduce task. So this is how job processing will be handled in Hadoop 1.x version, which is classic MRV1. Job tracker scheduling the job on task trackers and task trackers processing the job with the help of mappers and reducers. The main drawback of Hadoop 1.x version is mappers and reducers have fixed number of slots. Correct, we have discussed. When mappers are running, reducers sit idle. When reducers are running, mappers sit idle. Hadoop MapReduce or MRV1 is mainly flexible for batch processing jobs. That is, you can submit only Java programs only. Now let's see what happens in Hadoop 2.x. Hadoop 2.x, which is known as MRV2, MapReduce version 2, or popularly known as YARN architecture. In YARN, what happens, whenever application team submits a job, the job will be handled by RM, resource manager. Resource manager will be having the complete information of the cluster. Now here how the job tracker is taking the order or giving the order to the task trackers, the entire computation in 2.x will be handled by node managers. In the node managers, these are the slave daemons. Okay, in Hadoop 2.x we have a slave daemons called node managers where the entire computation takes place. So here we have node manager 1, node manager 2, node manager 3. When it comes to processing, we call it as this as a node manager. When it comes to storage, we call this as a data node. Because data node stores the data here and node manager processes the data. Right. Now say for example, in a cluster, it should have resources, right? The configuration. For example, I'm taking 10 GB RAM, 10 GB hard disk, and 5 vCore. Every machine is having a configuration 10 GB RAM, 10 GB hard disk, and 5 vCore. So what is the total cluster capacity then? 30 GB RAM and this is 10 GB RAM, 10 GB RAM, 10 GB RAM. So what is the total cluster capacity? 30 GB RAM. Hard disk 10, 10, 10, 30 GB hard disk, and how many cores? Total 5, 5, 5, 15 cores it will process. So this cluster can maximum process 30 GB of data, 30 GB of hard disk, 30 GB RAM capacity, and using 15 vCores only. Any job which requires 31 GB, this cluster will not process, right? Now these node managers will be sharing their information to the resource manager. so that this resource manager will know the entire cluster capacity. So 30 GB RAM, 30 GB hard disk, and 15 V cores. It can be quadra or tetra, something like that, but 15 V cores. So the resource manager will have this cluster capacity. Now say for example, an application has submitted a job and this application requires 12 GB RAM, 12 GB hard disk, and 6 V cores. How much memory is required to run this job? 12 GB RAM, 12 GB hard disk, and 5 V cores. Whenever the client submits a job to the resource manager internally has two important components. Here, both the scheduling part and monitoring part is taken care by the job tracker. But in 2.x version, this part is divided into two parts. First one, there is a scheduler. The resource manager internally has two components. One is scheduler, and then the other one is application manager. Remember these two, write down. The resource manager has internally two important components. One is scheduler and the other one is application manager. Now let's discuss about the scheduler and application manager now. Whenever resource manager gets a client request to process any job, it will internally check with the scheduler. Now the scheduler will schedule the job. For example, you go to railway station and there is 9 o'clock, you are boarding on train. Now there will be an announcement, right? Where on which platform the train will be coming. That announcer will announce and just stop it. Whether the train comes fastly, slowly, he doesn't mind, right? He will simply schedule the train to platform number 1, right? Likewise, there is a 3 types of schedulers. FIFO. What is FIFO? First in, first out. And we have capacity scheduler and fair scheduler. Very, very important interview question. What are the 3 schedulers in Hadoop? We have FIFO scheduler, capacity scheduler, and fair scheduler, right? So for time being, FIFO scheduler means first in, first out. Those who stands in the first will get the first priority. Now, this scheduler has scheduled this job in node manager 3. Let us assume. The scheduler, according to the scheduling, has scheduled this job to run on node manager 3. That's it. Its job is done. The scheduler doesn't mind whether the job is running properly, whether the job is running slowly, whether the job is running or not. It doesn't matter. It simply schedules the job. So this scheduler says that, okay, resource manager, I'm scheduling this job on node manager 3. Wonderful. Now, what does this application manager do? Now, this application manager will check with the client configuration, whether the client has submitted the correct jar file, whether the correct submission, what are all the job requirements, like how much memory is required to process the job and every information. Job configuration will be handled by this application manager. Now, this application manager, what it does is, it will launch a first container, very, very important, in the node manager 3 to process this job. The first container launched is known as AM, application master. Very, very important. Application master. So what does this application master do? This application master will now act as a short-term job tracker. So what is the responsibility of job tracker? To take care of the entire life cycle management of the job, right? Now this application master is responsible to complete this user job. Now this application master will check this resources. What is the resources in this machine? 10 GB RAM, 10 GB hard disk, 5 equals. Now this application manager says that, hey application master, take care of running this job which requires 12 GB RAM, 12 GB hard disk and 5 equals. Now this application master from this mission will launch a new container to process this job. A container is nothing but a combination or a mixture of CPU, hard disk, RAM and cores, right? So this application master will now launch a container which will be utilizing this system's resources. As no job is running, 10 GB RAM, 10 GB hard disk and 5 eCores will be utilized for this job now. Here this container will be launching with 10 GB RAM, 10 GB hard disk and 5 eCores. But do this memory is enough to run this job? No, right? It requires additional memory. Right? How much additional memory it requires? Additional 2 GB RAM, hard disk and 2 eCores or 5 eCores is sufficient. Now this application master, what is cores processor i5, i7, what are those? Your cores to process, how big the cores are, your processing will be very fast, right? Virtual cores, right? Now, this application master will now directly contact the resource manager for additional resources. Hi, resource manager. I was given the responsibility of running this job. The job has a complete requirement of 12 GB, 12 GB RAM, 12 GB hard disk, and 5 eCores. But in my node manager, I have only 10 GB RAM and 10 GB hard disk. I need additional resources. Can you please provide me? Now this application resource manager checking this cluster resources, it will check. Total how much? 30 GB is there. Out of 30 GB, 10 GB is utilized here. 30 GB hard disk, 10 is here utilized. So remaining how much? 20 GB hard disk is there, 20 GB RAM is there. So this application master, the resource manager says, hey, you can run or you can use the resources from Node Manager 1 or Node Manager 2. Now this application master will continue running the same job utilizing the resources from any one of these two node managers by taking additional 2 GB RAM and 2 GB hard disk. So two containers are launched. This container is dynamically launched, if you see, according to the resources. All of you. Whereas in map reduce, fixed number of maps are there. Even though you require additional maps, these maps has to wait till their turn to process that and gets free and again reassign that maps to that particular job. But here if you see, if it requires 5 GB additional, it will take any of the resources to process this job. Okay. Right. So while this job is processing, how much cluster capacity is using? 12 GB, 12 GB, 5 equals. So the remaining is, what is the remaining cluster capacity? Out of 30, 12 is used, right? So 18 GB RAM is there. Out of 30, 12 is there. Again, 18 GB hard disk is there. Out of 15 equals, 5 equals are utilized. So 10 equals. So any next job or any job that is submitted now will be utilizing those resources only. Meanwhile, if another job is running while this job is submitting, there is no Uh, uh, uh. Okay. Once this job is done, your answer will begin. Now, this next job is done. Remember, for every job in application master is different. Means every job has its own application master. Say for example, application master 1, 2, 3. This application master is responsible for this job only. Once this job processing is done, the containers become free, and then the output is sent to the AM. The AM automatically gets killed and sends the output to the resource manager. Whenever the processing is done, this memory is again released. The containers release their memory. Means again, this 10 GB comes to this machine, 10 GB comes to this machine, 5 equals comes to this machine. Once the processing is done, like how the mapper 1 processes block 1 means, again mapper 1 has releases its own memory, right? Now another job has submitted which requires 15 GB, 15 GB and 8 vCores. How much? Next job is requiring 15 GB RAM, 15 GB vCore, hard disk and 8 vCores. Now whenever resource manager gets this request, again internally checks with scheduler and app manager. The scheduler now has to schedule this job. So it says that, okay, I'm going to schedule this job in node manager 1. Now, application manager, what it does, it will now check the job configuration of the particular file, right? So, and it will first launch a new container in the form of AM. So this AM will now take care of this job, right? Now AM will check the resources in this machine. Now in this machine, it has 10 GB RAM, 10 GB hard disk and 5 vCores. So it will launch the first container to process this job. Okay, but initially how much resources are required? 15 GB RAM, 15 GB hard disk and 8 vCores. But in this machine, it has only 10 GB, 10 GB, 5. So additionally, how much it requires? 5 GB RAM, 5 GB hard disk and 3 vCores. So while running this job, this application master will now reach to the resource manager saying that, hey resource manager, I need additional resources. Please provide them. Now this resource manager will check. As this job is utilizing here, there are no resources here. It can't give. Now it will check in this machine. Out of 2 GB, 8 GB is there, right? So out of 8 GB, it can give 5 GB, right? Again, 2 GB hard disk is utilized. Again, 8 GB is there. So it says that, hey, you can use the additional resources from node manager 2. Now this AM will now launch a new container, black color, right? So this same container in this machine to get the additional resources. So this 30 GB is now utilized by 2 jobs. One job is running with one application master, and then the second job is running with the second application master. I'm repeating again. In Hadoop 2.x, what we call it as a YARN architecture, the entire resources are managed by global resource manager, which is the master daemon. Now, whenever any job submission is done, this resource manager takes the request, and this resource management is divided into 2 parts, scheduling part and application management part. The scheduling part, according to the scheduler, FIFO, capacity and fail scheduler. We are taking FIFO, for example. Capacity scheduler, fail scheduler, I will show you how it works. But for now, understand that FIFO means first in, first out. Now the scheduler will schedule the first job, green color job. It says that, okay, I am scheduling the green color job in node manager 3. The application manager will now check the job configuration, whether all the required job parameters are set done. how much memory is required. Everything information it will get from the application manager, and then it will launch a new container in the form of application master. For every job, there will be a unique application master. The application master is like a short-time job tracker. Means this application master will now take care of this job. Either the job is failing, either the job is wants rerun everything. This application master only will take care. Now this application master will launch the container because in Hadoop 2.x we don't have map tasks, reduce tasks. We have dynamic containers. A container is nothing but a combination of CPU, hard disk, and memory. So this application master will now launch a container from this machine. Now this machine has 10 GB RAM, 10 GB hard disk, and 5 cores. But this job needs an additional 2 GB hard disk, 2 GB RAM, and no cores are required. So this application master will now reach to the resource manager for additional resources. Hey, resource manager, I'm short of resources. Please provide me additional resources so that I can process this job. Once it gets the resources from the resource manager, it will launch the container in second mission, and then it will utilize these resources to process this job. Once this job is processed, this 2 GB, 2 GB will be released, means the container gets killed. 10 GB, 10 GB, 5 cores gets killed, means released, and then this application master will kill itself because its job is done. And then this output will be sent to the resource manager. In this way, the resource manager will handle the request. Now, by this time, a new job is submitted. Suppose I have submitted another job. This is your question, right? Now, this job requires 5 GB, 5 GB, 2 cores. 5 GB, 5 GB, 2 cores. Now, how much this job is running? 10 GB, and this is 12 GB. The second blue color job is running with 15 GB. So 12 plus 15, 27 GB system is already utilized. Again, 10 plus 12 plus 15, 27 GB hard disk is already utilized. Here 8 cores and here 5, 13 cores are already being utilized. Now, what is the cluster capacity now? No. While these two jobs are running, I'm telling. While these two jobs are running, what is the additional? What is the remaining? 3 GB RAM, 3 GB hard disk, and how much? 2 cores, right? While the new job is submitted, what is the new job requires? 5 GB, 5 GB, 2 cores. But what is the remaining? So this job will be in accepted state. It will be in a queue till the memory is free, and once the memory is free, then the resource manager will ask this scheduler to run this job. So it will be in waiting state. Okay, it will not get the resources. Clear in everybody? They will ask you what is yarn architecture. Please explain. So you need to explain in a neat way. For example, can anyone come here? Anyone come here for a while? Red t-shirt, red shirt. Speak loudly and stop. Don't feel shy. Don't feel nervous. Okay. Say confidently. Yeah. Read loudly. Hello. For you only. Redesigned
resource manager. It at the time of its
launching.
but to know has a large scale distributed operating system used for big data processing.
You see here, we have the clients submitting the jobs to the job tracker, and again job tracker is giving the job to task trackers in turn are running map tasks and reduce tasks. This is 1.x, right? Now yarn architecture basically separates resource management layer from the processing layer. In Hadoop 1.x version, the responsibility of job tracker is split between the resource manager and application manager. Now, if you see this diagram, we have a storage part, and on top of that, we have a resource management part handled by yarn, and then it can process previous jobs. MRV1 jobs means Hadoop 1.x plugins, 1.x plugins, MapReduce jobs, batch processing jobs, plus other data processing means real-time streaming, live streaming, interactive jobs as well.
Also allow different data processing engines like graph processing, interactive processing, stream processing, as well as batch processing to run and process the data stored in HDFS, that is Hadoop Distributed File System, thus making the system much more efficient. Through its various components, it can be dynamically allowed various resources and schedule the application processing. For the large volume data processing, it is quite necessary to manage available the resources properly so that every application can leverage them.
What are the yarn features?
Yarn features. Yarn gently popularity become of the following features. First one is scalability. Scalability means the scheduler in resource manager of yarn architecture allow Hadoop to extend and manage thousands of nodes and clusters. Second one is capabilities. Compatibilities. Yarn support the extensing MapReduce application without disrupting, thus making its compatibility with Hadoop 1.0 as well. Third one is cluster utilization. Since yarn support dynamic utilization of clusters in Hadoop, which enable optimized cluster utilization. Fourth one is multi-tenancy. It allows multiple engine access, thus giving organization a benefit of multi-tenancy.
Now, multi-tenancy means different forms of applications, like not only Java MapReduce, streaming jobs, graph processing, all comes under tenancy. Okay. Now, if you see the yarn architecture, just now we have discussed, clients will be submitting the jobs and yarn resource manager will take the request, and then this request is given to the node manager. Means all the job computation will be handled in node manager, and this node manager is having application master. For every job there will be a unique application master which runs the container to process the job. Okay. Now good.
Submit MapReduce job. Second one is resource manager. It is the master daemons of a yarn, and it is responsible for resource assignment and management among all the applications. To a processing request, it forward to the corresponding node manager and allocate resources for the completing of the request accordingly. It has two major components. First one is scheduler. It performs scheduling based on the allocated application and variable resources.
Available resources. Yeah.
From other tasks such as monitoring or tracking does not guarantee a restart of if task is failed. Support plugins such as capacity scheduler and fail scheduler to partition the cluster resources.
Fail. Yeah.
For accepting application and negotiating the first container and the resource manager. It is also restart the application master container if task fails.
Okay. Application manager responsible. Now the node manager. Yeah.
Another one is manager. It takes care of individual nodes on Hadoop cluster and manage application and workflow that particular node. It is
on that particular node. Okay, try to understand and read. Okay, yeah. Stop where you are getting full stop. Yeah.
manager and send hard status
How's the status of the node? Means I told you right, its information will be sharing to resource manager via heartbeat, right? Yeah.
It's monitor management and also kills the container based on the directions from the resource manager. It is also responsible for creating container process and start it on the request of application masters.
Wonderful. Now, what does application? These are very, very important technologies. Okay. Yeah.
To a framework, the application master is responsible for negotiating resources with the resource manager, tracking the status and monitoring the process of the signal application. The application master requests the container from the node manager by sending the container launch contents, that is CLC, which includes the everything an application need to run. When the application is started, it sends the hard health report to the resource manager from the time to time.
So this is all about application master.
Container. It is a collection of physical resources such as RAM, CPU, CPU cores, and the disk on a single node. The container are, the by container launch context, a CLC, which is record the contents information such as environment variable, security token, and dependence.
Now, how the job will be executed? First of all, if you see number one, client is connecting to resource manager. Now, two, resource manager with the help of application manager and scheduler, it is not written. Application manager it is given directly. So step number two, it goes to the application manager. Now this application manager is checking with the resource manager for the resources as well as where to schedule. Now 3 and 4, if you see, once that is done, what is the fifth step? The job is scheduled on the node manager, right? So once the job is scheduled on the node manager, 5, there is that 6. Yes, again, the client, it is getting the resources, what required from the client, and then the resource manager is sending the job. In this application master is to the resources to the resource manager for additional resources or whatever, and then the job is processing, and again the request is sent back. Can you please read this? What is the step one? Client submits an application. 1 second. Let me copy this into a notepad, and then we will start. Downward arrow. Downward arrow. Hang on. Okay, what's the first step? Client submits an application. So client submits an application to the resource manager. Read this. So the resource manager is now allocating a container to start the application manager. Next,
The application manager register itself with the resource manager. The application manager views the container from the resource manager. The application manager notifies the node manager to run the application node is executed in the container. The client contacts resource manager, the application manager, to monitor the application status. Once the processing is complete, the application manager unregister with the resource manager.
Take the screenshot of this diagram. Screenshot of this diagram for better understanding. Done, right? You have already video. And again, in the video you will get right. Okay. One second. You need to understand the yarn architecture very. Yes. Now you see here, everybody, you have a resource manager and 3 node managers, right? Now there is 2 colors. One is purple, one is pink. Let's assume these 2 clients are connecting to the resource manager, and then this resource manager has to process these 2 jobs. For example, let us assume that a pink color job has started first. Now the resource manager, with the help of application manager and scheduler, has scheduled the app master for the pink color job. Now this application master is looking for the resources. Already second container is running. A container is running for different job. So no resources are available in this node manager. So the application master is checking with resource manager for additional resources. Once this resource manager allocates the resources, this app master is launching container on this mission, and this application master is launching container on this mission. So this job is handled by this application master with the help of 3 containers. Likewise, for the client, there is another application master who is launching container on this mission. In this way, the job will be monitored. The resource manager has 2 important components.
The resource manager has 2 main components. First one is scheduler and application manager. The scheduler is responsible for allocating resources to the various running applications, submit to familiar constraint of the capacities, fuel, etc. The scheduler is pure scheduler in the sense that is perform no monitoring or tracking of status for the application. Also, it offers a guarantee about restarting failed tasks. The scheduler performs its scheduling function based on the resource request
Of the applications.
It does so based on the abstract notation of the resource container, which includes elements such as memory, CPU, disk, network, etc.
So if anyone asks me what is the container, what is the combination of memory, CPU, disk, and network, right? So these are the terminologies you should know. Now you should be able to understand how Hadoop 1.x is designed and how Hadoop 2.x is designed. In Hadoop 1.x, the storage part is same, but the block size is 64 MB. In 2.x, the storage part also same. Blocks are different, but the block size is 128 MB. Hadoop 1.x has map-reduced processing, which supports only batch processing already gathered data. And again, we need to submit any map-reduced job in Java only. It has the ability of fixed number of slots only, but map are reduced slots. And again, we have a single job tracker cluster. Now, considering all these drawbacks, they have created a new framework in 2.x version. Where in 2.x version, the job tracker is replaced with resource manager. Now, this global resource manager has the ability to run previous lectures math job, that means math processing job, as well as real-time naming job, app processing job,
Right.
street jobs, whatever job you submit, you can't have the ability to process that job. Now, how it is processed with the help of containers, dynamic containers, right? With the help of application masters of containers, Yarn is able to allocate the resources. I consider the resource allocation is 100%. No matter no resources, nothing is decided. If I need additional resources, I can ask resource manager, and if the resources are available, immediately the resource manager is allocating them, right? So this is all about Hadoop 2.x YAML architecture. Now let's talk about high availability architecture. Thank you. Real time? I'll show you with example. 2.x. I didn't install 2.x, right? I will take your Cloudera 2.x machine and I will submit the job and I will show you how it works. Okay. The extra memory in the system, that capacity is only registered with resource manager. That will taken care by application manager, right? So application manager will take care of that. No need of additional resources for app master. It will use the JVMs, right? JVMs are there, right? It will use that, right? Now, there is one more important topic called rack awareness and name node high availability. Let's discuss that. This you should understand. Now in Hadoop 1.x version, you have a single name node, right? Single name node and single job tracker. What we call it as single point of failure. Means if name node goes down, entire cluster is down. If job tracker goes down, your processing part goes down. So in order to overcome this single point of failure, we have a new concept called name node high availability. High availability concept introduced in Hadoop 2.x onwards. So what is this high availability concept? Unlike 1.x version where you have a single name node, in Hadoop 2.x onwards, you have two name nodes. How many nodes? Two name nodes, which we call it as active standby. Active standby. So what is this active standby name node? Who will decide? Simply in this group, I cannot say that, okay, red shirt, you are the leader. This is not a fit. If I want to elect a class leader from this group, I cannot simply say, okay, you are the leader. I will be a little faster, right? So what if I conduct a test? And what if I tell whoever scores 90% will be the class leader? Now, people are very opportunity to everyone to become leader, right? So that who scores 90% will become the leader. No matter, right? So that person who is taking care of that condition and everything is known as zookeeper. So zookeeper is like a distributed coordinating service. What is this distributed coordinating service? Now in a production cluster or in a multi-node cluster where multiple missions are talking to each other, if any mission goes down or if any mission is not working, it will be a difficult task for the system administrator to understand which mission is working and which mission is not working. it will take some time to identify, right? The error. But with the help of zookeeper, the administration task will be reduced. It will identify immediately and it does the next action, what to be done. So zookeeper is a distributed coordinating service which has two important features or functions. One is leader follower selection. Leader follower selection means out of a group of missions, it will select leader and the remaining will become the followers. Leader follower selections. Second one, automatic failover mechanism. Automatic failover mechanism means if any mission goes down, it automatically does the failover. Normally, high available environments require zookeeper. Zookeeper should be order of odd numbers. Odd numbers means 1, 5, 7. 1, 3, 5, 7. Why we are installing zookeeper in the odd numbers is they can tolerate failures up to n minus 1 by 2 times. N minus 1 by 2. For example, if I have 2 missions, 2 zookeepers, n minus 2, n minus 1 means 2 minus 1, 1, 1 by 2 means mission is not completely available. 3 minus 1, 2, 2 by 2, 1 mission still I have availability, right? So in case of failures, it has the tolerance up to n minus 1 by 2 times. So zookeeper should be installed in a cluster in the order of odd numbers. Normally in my cluster, we have 3 zookeepers. Right? Now there is 2 name nodes, NN1 and NN2. We have not yet decided who is the active and who is the standby. There are 2 name nodes. One is NN1, one is NN2. Now we have all the data nodes, right? So what do the function of data nodes? What does data node do? Huh? It stores the actual data, right? Now all these data nodes will be sending heartbeat signals to name node, right? So this is data node 1, data node 2, data node 3, and data node 4. If you see here, in a high available architecture, with the help of zookeeper, what we call it as forum peer. Forum peer. Now, there are 4 data nodes. How many name nodes are there? 2. So in a high availability architecture, all the data nodes will be sharing the heartbeat signals to 2 name nodes. Means data node 3 is sharing its metadata information to, heartbeat signals to name node 1 and name node 2 as well. So that both the name nodes are knowing the complete details of the data nodes, right? So they are aware of how many data nodes are there and how many data nodes are up and running. Correct? Understand this? Okay. Now, both the name nodes are having a complete information of this data nodes. Now, who will be made the active name node and what is the responsibility of active name node? Now the zookeeper will trigger a condition for these 2 name nodes to become leader. Okay. Say for example, these 2 name nodes are given the opportunity to maintain a lock with zookeeper, what we call it as electoral lock ID. Electoral lock ID. Whoever maintains that electoral lock ID, electoral lock ID with zookeeper, it will become the leader. or it will become active name node. Say for example, this name node one has maintained the lock condition. It has maintained the condition with the zookeeper. So this has become the active, and the other one which fails to maintain the lock ID with the zookeeper will become standby. Till now clear in it? All of you, right? Now, what is the main responsibility of active name node? Like in single point of failure, whenever applications connecting to name node, what name node is doing? It is maintaining all the metadata, right? It is responsible for taking the request, right? Likewise, the name node which is active, the name node which is active, okay. Now in 1.x version, we have given in the core-site.xml that fs dot what is that name? Default file system name, fs.default.file system localhost 54310. Its value. We have given the in the core-site.xml, if you remember, we have given name node addresses HDFS localhost 54310. As it is a single node, clients will be connecting. But here, how many name nodes are there? 2 there. And I do not know which is active and which is standby, right? Because the clients doesn't know which is active and which is standby at that time while they are connecting. So what we do is we will create a logical namespace. Means instead of HDFS localhost, I'll create a logical name, like any name. For example, my cluster or any name I'll give. Logical namespace. Say for example, my cluster. Now the clients will be connecting to this name, my cluster name. My cluster internally has 2 name nodes, right? Now this cluster, what it does is it will route this request to whichever name node is active. For example, name node 1 is active at that point, it will route the request to name node 1, because the name node which is active has the privilege of creating the client request. Suppose at this point of time name node 2 is active, this request will be routed to NN2. So for logical representation or namespace, we will create one name, logical name called my cluster or any name. You can give any name, so that the external clients will connect to that logical namespace, and that namespace will route the request to the name node which is active. If it is NN1 active, the request will go to NN1. If the NN2 is active, then it will go to NN2. Wonderful. Let's assume that NN1 is active. Whenever you are doing modifications to Hadoop cluster, what is name node doing? Whenever you are doing modifications to Hadoop cluster, what is name node doing? Edits log file, right? Means it is doing the modifications. So where do this edits log file store is the first question. We will be maintaining the edit log files in a special nodes called journal nodes. Very, very important. Journal nodes. Journal nodes should also be in the form of odd numbers. Journal nodes. So journal nodes are the place where active name node will be writing the modifications to the Hadoop cluster. In other words, all the edit logs will be written to the journal nodes. Now this active name node is writing the edit logs. Suppose transaction 1. First, HDFS DFS -mkdir AVD. So in the operation code, what it is doing? Operation code AVD transaction ID 1, right? So This transaction ID 1 will be written on all these 3 journal nodes at a time. Okay, likewise, all these edit logs will be maintained. Now, what do the standby name node does is, in order to sync the standby name node with the active, because both the name nodes are having all the data nodes information, correct? And this active name node is having the metadata information. Now, in order to sync this standby name node with active, what do the standby name node do is, it will continuously read the edit logs from the journal nodes. Now you tell me, both the standby name node and active name node are in completely sync or not? Standby name node. Now active name node is writing the edit logs information here. This standby name node is continuously reading whatever active name node is writing. So at any point, active name node and standby name node having complete information, right, of the file system, all of you. Now, who will maintain the health of this active node and who will maintain this health of the standby name node? Zookeeper with the help of a service called ZKFC. What's the name? ZKFC, Zookeeper Failover Controller. Zookeeper Failover Controller, very, very important. ZKFC. Failover controller will monitor the health of these 2 name nodes. Means Zookeeper Failover Controller service will be running on this mission. Zookeeper Failover Controller service will be running on this mission. Now this active name node will be sending a heartbeat signal to Zookeeper Failover Controller service. This standby name node is sending a heartbeat signal to ZKFC. Till now everything is clear and 6 to 7 a.m. Same at 7:01 a.m. This active name node is not sending signal to Zookeeper Failover Controller. Immediately this Zookeeper Failover Controller observes that, hey, there is an issue with active name node. It is not responding. Maybe disk pull, it is not sending signal. Immediately what it does is, it will kill this process. Once this process is killed, what is the other name node? Standby. Now what does this Zookeeper will do is, hey, standby name node, now you are the only one. If you try to maintain the lock ID, you will become the active, right? So as it is the only one mission up and running, it will now catch this lock ID, because all this process ID of lock ID and everything will be get killed, right? Now this standby ID, standby name node will maintain the lock ID, and then it will now become the new active name node. Now clients will be now connecting to the request to this active name node. Now this name node is dead, right? It's down, right? Immediately, thus Zookeeper what it does is, hey, you are now standby. Means you need to now take the request from this edit logs. You have to continuously read the edit logs information. Now NN2 is the active, not you are the active. If it feels that you are the active, no, I have killed all your processes. Now standby name node NN2 is now active. It is now taking the client's request and it is now writing the edit logs to the journal nodes. Following in very, very important concept. Let me explain you one more thing. Name node high availability. Name node high availability, which is very, very important. What does this diagram say? You have how many name nodes are there? 2 name nodes. One is name node active, name node standby. And if you see data nodes are there, 4 data nodes are there. All the data nodes are sending signals to both this name node NN1 and NN2. Now, there are a cycles called zookeeper, which is maintained in the order of 3. 3 zookeepers are there with automatic failover and foreign journal manager. Now see, whatever clients are doing modifications, this name node is writing those edit logs to journal nodes, and this scanner name node is reading all those information from the journal nodes. The health of the name node is maintained by failover controller. This health of the name node is maintained by this failover controller. What is written here? It monitors the health of the name node, its operating system and hardware. Likewise, what are these data nodes are sending? Log reports to active and standby. Data nodes can only obey commands from active. So whichever is active, name node then only has the privilege of writing the information to the journal nodes. Okay, take this diagram as well. Very, very important. If you want this one or simply this, anything is feasible, anything is okay. Zookeeper, okay. Now, lock ID means condition. Whoever meets that condition, he will get the lock ID. Condition, zookeeper will tell to that name node. It will not tell to you. It says that okay, whoever maintains this lock ID, this process will become the leader. It's internal process. Okay, it's internal. Nothing to worry about that. Zookeeper will immediately make this standby leader. Which one? The process, see, both the active and standby are in sync, right? Or in sync means at 7:30, the active name node is down. Till 7:30, what is happening? All the data nodes are sending the signals to both. Take the chair. Bring the chair. Bring the chair. Here there is a chair, right? If gatekeeper fails to zookeeper will not fail it. Yeah, tell me. Both name node are very, very important question. Once this is done, I'll tell you. Very, very important question. Read louder. Please keep quiet, all of you. See, you don't have days to come here and you can't speak when I'm giving you open offer and you are listening, okay? That's why I'm following from this one to one.
Zookeeper is the coordination service for distributed application. Zookeeper is a coordination service for distributed application. Well, what the heck is that, right? Glad you asked. If you are looking to understand what is Zookeeper and to understand its use case or the problem Zookeeper is trying to solve in a little bit of depth, you have to come to the right place. zookeeper's documentation even doesn't do a good job of explaining what is zookeeper in simple terms and its use case. So we thought we will use it, we will give it a shot. Imagine you are a kindergartner teacher and you have 15 kids in your class. You would like to elect a class leader. You, as the teacher of the class, can pick a kid of your choice to be the class leader, and that won't be fair to the other kids. So you tell your kids the kid who jumps the highest will be the class leader. I know that is lame and a terrible method to elect a class leader, but nevertheless, in the class leader election process, you, the teacher, become the coordinator. Here, in the class leader election process, the teacher is the zookeeper and the kids are distributed applications. Zookeeper is an open source Apache project usually installed on 3 nodes, and the 3 nodes form the Zookeeper cluster or quorum. The Zookeeper cluster is then used to coordinate certain activities between distributed applications. And yeah. In this post, we will see how Zookeeper is used to achieve high availability in Yarn. Manager in Yarn is a single point to failure, meaning if we have resource manager running on only one node and when that node fails, we have a problem and we won't be available to run any jobs in our Hadoop cluster. To avoid resource manager to be a single point of failure, we need to enable high availability with resource manager. This means we will run another resource manager instance on another node in standby mode. When the active resource manager fails with high availability configuration, in the place, the standby resource manager will take the role of the active resource manager. Now, when the active resource manager fails, we can manually fail over the resource manager, so the standby resource manager will become active. This means there is manual intervention involved from the Hadoop administrator to initiate the failover. In a busy and highly active production cluster, manual failover is not a great option because you will lose valuable time in contacting the administrator and initiating the failover. The other option we have is automation failover. We can configure Zookeeper to do an automation failover of the resource manager when the active resource manager fails. How does Zookeeper help or facilitate the automatic failover? There are two things we want to understand here. How Zookeeper is used to elect the active resource manager when there are more than one resource managers. This is referred to as a leader election. How the Zookeeper handles automatic failover, that is, how does a standby resource manager becomes active in an event the active resource manager fails.
So these are the responsibilities of Zookeeper. Leader follower selection and automatic failover management.
Leader election is one of the common use case for Zookeeper. Let's see how it works. As an application using Zookeeper, you can create what is called a Z node in Zoo. Okay, Z node in Zookeeper. Z node in Zookeeper looks like a file system structure with folders and files. For example, in this illustration, Tom is a Z node and it has two Z nodes under it, Sam and Emily. Emily has two more Z nodes, John and Riley.
And again, it has two more subdirectories which are
We can also embed data in each Z node if we like. You cannot embed a lot of data. You can embed less than 1 MB.
means every directory can store up to 100 data. Like minus 2, not for 10 and 20 MB. Zero. 100 data. What is this 100 data consists of? The data follows selection process.
Let's say we have two resource managers. Each resource manager will participate in the leader election process to decide who becomes the active resource manager. Resource managers use Zookeeper to elect a leader among themselves. Let's see how it works. Both resource managers will attempt to create a Z node named active standby elector lock in Zookeeper, and only one resource manager will be available to create active standby elector lock Z node.
So data selection.
Whoever creates this Z node will yes. Whoever creates this Z node first will become the active resource manager. So if resource manager 1 creates active standby elector lock first, it will become the active node. And if resource manager 2 creates active standby elector lock, it will become the active node.
So whoever created that login will become active.
Let's say resource manager 1 created the active standby elector lock Z node first. Resource manager 2 will attempt to create active standby elector lock, but it won't be available. And because active standby elector lock is already created by resource manager 1, so resource manager 1 becomes the active resource manager, and resource manager 2 becomes the standby node and goes in the standby mode.
Clear, right, everybody? Alright. Now we have it. Active node or active resource manager as standard development. Working on. In this we have discussed that Z nodes are different. There are two types of Z nodes. One is ephemeral Z node and critical Z node. Okay.
Ephemeral node. There is an interesting thing about active standby elector lock Z node. It is a special kind of Z node. It is called an ephemeral node, meaning if the process creating an ephemeral node loses its session with Zookeeper, the Z node will be deleted. Meaning when the resource manager 1 goes down or loses the session with Zookeeper, active standby elector lock will be deleted.
So this information is stored in ephemeral node. So once active node loses its connection, this data in ephemeral
Resource manager 1 will also create another Z node named Z node active breadcrumb. Active breadcrumb Z node is not an ephemeral node. It is another type of Z node called persistent node, meaning when resource manager 1 goes down or loses the session with zookeeper, unlike active standby electron lock Z node, active breadcrumb will which is persistent Z node does not get it. Resource manager 1 will write information about itself, the host name and port of resource manager 1 into the active breadcrumb. This way anyone can find out who is the active resource manager at any given point.
So from this we know we can write the node, which level is active button point. That is the button. And we want to use the right side, right? After the video that is
Okay. Failure.
Failover. With Resource Manager 1 as the active node, everything is working good up until one fine morning when the RAM in Resource Manager 1 has gone bad. So Resource Manager 1 went down. Now our expectation is Resource Manager 2 should be become the active node automatically. Let's now understand how failover from active node to standby node works.
okay. Now,
With Zookeeper, we can add watch to any node. Watches are extremely helpful because if we are watching a Z node and when that Z node gets updated or deleted, whoever is watching the Z node will get notified.
so we will keep watching or maybe one of the two. Right? Now you can
Remember, whoever creates the active standby elector lock ephemeral Z node first becomes the active resource manager. In our case, resource manager 1 beat resource manager 2 by creating active standby elector lock first. When resource manager 2 tried to create active standby elector lock Z node, it couldn't because it was already created. So resource manager 2 realized that there is already an active resource manager elected and it becomes the standby node. Before resource manager 2 becomes standby, it will add a watch on the active standby elector lock Z node.
this is how
Give me 2 minutes. Give me 2 minutes. Come. Two minutes. Give me 2 minutes. Please wait. I'll call 2 minutes. Give me 2 minutes. Okay. Please. I'm just sending one email. After that, we can do. Don't make noise, guys. Now we are into the web UI page of. Now here you see very important and in 1.x version you have discussed about the map reduce administration. Now in 2.x version we have a cluster page, resource manager page. Now towards your left side, this is very important. Towards your left hand side, what are the job status? New saving, submitted, accepted, running, finished, failed, killed. So any job in 1.x version we call it as a job. In 2.x version we call it as an application. Both are nothing but any program that you have submitted to Hadoop cluster in the form of a jar file. So in 2.x onwards we call it as an application. In 1.x version we call it as a job, right? Now here you see apps submitted, apps pending, running, apps completed, all 0 because we have not submitted. What is the total memory? 8 GB is the total cluster memory here. How many vCores are there? 8 vCores. So this cluster can process any job which is having a capacity of 8 GB and 8 vCores. Which is beyond 8 GB and 8 vCores, it is unable to process. Point number 1. Now, what is the scheduler type? Capacity scheduler. What are the 3 schedulers available in Hadoop? FIFO scheduler, capacity, and fail. Right? Now, minimum allocation. What is this minimum allocation? In order to run a job or application, a container should be running, right? So the container should have minimum 1024. What is mean? 1 GB, right? So a container will be launched with minimum 1 GB RAM and 1 vCore. A small job will be running with this memory. Maximum how much? 8 GB will be replaced. So let us run one job here. Go back to your terminal. The command to start the cluster is start-dfs.sh, start-yarn.sh. Where is your Hadoop installed? User local Hadoop, etc Hadoop, right? So go to slash visible right font size should increase. Right? Now user local Hadoop configuration files are there. Here if you see there is a share folder. CD share ls space -ltr. There is a Hadoop and doc. Go to CD Hadoop ls space -ltr. Now there is map reduce is there, yarn is there. You can select anything. CD map reduce. Now here you see map reduce hyphen all the jar files are there here, right? You can see all the jar files. Examples.2.9.2. You can see the same examples.1.2.1 jar file in 1.x version as well, right? So enter. You can either type Hadoop, enter. What does it say? Hadoop space jar to run a jar file. So what is the command to run a jar file? Hadoop space jar, and it will ask you what is the jar file name. Here we have Hadoop hyphen map reduce hyphen examples. Map reduce examples means 1.x version program files, right? All of you. So to test a job, what is the program we have selected? Which program we selected in 1.x version to test our cluster? Which job? PyJob, right? So upward arrow, Hadoop jar, Hadoop jar, just select Hadoop hyphen map reduce hyphen examples 1.2. Now again you can see an example program must be given. These are all the jars, right? Now what is the program we are running to test our cluster? PyJar. So upward arrow Hadoop jar, Py, and then I'm just giving 2 mappers, and for 2 mappers, 2 samples. First of all, see what is happening. Now it is connecting to resource manager. Resource manager, then it is submitting a job. For every job, there will be a job ID, right? Now let's go to this Mozilla Firefox and see what is happening. Refresh. How many containers are running? 1 container. How many memory is used? So out of 8 GB, 2 GB is used, right? Refresh. Again, how many containers are running? 3. 4 GB's memory is used. Means for this job. Refresh. Again, it is 1 app running. Again, it is time. Again, how many containers now? 2. Means reducer phase it is going. Again, refresh. Once the job, now again, only 1 container running. Now, once the job is done, the container gets killed, right? Let's see whether the job is, now you see, job state is how? Finished. How many containers running? 0. Again, the memory has been retained to 8 GB, right? All of you. This is one way of knowing how your job is running in the cluster. First way. Now you see here how the stats and everything, right? Job completed successfully. Number of splits 2. What is this splits? We'll be understanding soon. Note on this point, splits. Okay, very, very important. Now let us see how this job is handled. Whenever application master is launched for any job, it will launch the containers, right? That is what we are seeing, right? Now let us see how this job is launching containers. Enter. Now here you see, if you do JPF here, enter. Now any new JPS you see here, MR app master. So an app master is launched. The app master requirement is to run the containers, right? So mapper 0%. If you see the below, 0% is there. Now yarn child. These are containers running. Now map 100% is done. Let's see how many containers are there. Only 1 child jar is there. Now reducer phase, right? Yarn child. Again JPS. Now job is done. Once job is done, this child jar as well as MR app master will be completed. And once again repeating, once you submit any job here, the application master will launch the scheduler part will launch the container in the form of app master. The app master will now launch the containers, right? The containers are nothing but yarn child jars in the JPS, right? So let's see again. If I give 3 mappers and 3 samples, not reducers, okay? Now here you see JPS. Check the below window and this JPS simultaneously. How? Now here you see running job. Now MR app master is allocated. Still mapper phase is not started. So no containers have been launched now. JPS. Now you see yarn childs are running, means containers are launched. Mapper should go ahead now. From 0% to it should go to some 30% or 40%. See, 100% done now. Now again JPS. Now reducer phase will start. There is only 1 yarn child, means only 1 container running. Reducer phase is also done. Means your program is done. MR app master will get skilled, and again memory will be come to 8 GB, right? So JPS enter. Are we clear on this? yarn architecture. Now I told you Hadoop is a write once, read many times architecture, right? Means Hadoop supports appending but not modifying. For example, CLER clear, HDFS, DFS, -ls /. Now, what I do is go to cd/home hd user ls-ltr. You have a my data. I'll create one file sudo nano sample file Hadoop. Welcome to Hadoop. HDFS MapReduce Hive Scoop. This is a file, sample file. Now, what is the command to place this file into Hadoop? Put command, wonderful. So you can either use Hadoop FS or HDFS DFS, home, HD user, sample file to, I'm just giving sample file. It will be placed in, oh sorry, hyphen put, right? Hyphen put. I'm placing this file into sample file. Now HDFS DFS hyphen LSR. You will be seeing a sample file here, right? The same thing you can see in name node web UI as well. What's the name node web UI port number? 50070. Localhost :50070. Go to utilities, browse the file system. In the search button, just type / or else temp and user. Click on user. Under user again, HB user. Now there is a file called sample file, right? The size, block size in 2.x is 128 MB. What's the replication? 1. And you know, the owner is HB user, group is SOPA group. The file size given is only 44 bytes. If you want to read that, it will ask to download or not. For every block, there will be a pool ID. Every block has a Unix block ID. Now let's keep the same file again. What happens if I do the same command? What happens? Tell me. Sample file exists. Now, for example, sudo space nano, sample file 1. Now I'm just giving Spark, Kafka, Zookeeper, okay, and then Azure, AWS, GCP. Control X, Y, enter. Now I have a new file, sample file 1. If I do Hadoop or HDFS-DFS sample file 1 to the same file, what it says, write once, read many times. It will not allow you, right? But what if I want to append this data to this existing file? I told you, right? Hadoop supports appending but not modifying. If you type HDFS DFS, append, this is unstructured, right? It's a text file, right? You're just typing text file, right? Map, reduce and everything, it's a text file, right? You can do unstructured as well, but for our understanding, I'm taking, what is the first option? Append to file. Any new command, HDFS, DFS, -help. What is that? Append it to file. What does it say? Appends the contents of all the given local files to the given destination. The destination file will be created if it does not exist. If local source is dash, then the input is read from stdin. So I do hdfs dfs hyphen append to file. If you see here, what is the file says? See 44, right? After appending, it should add, right? Now go to the terminal, append it to file. What's the file name? Home HDOZ sample file 1 to. We are appending this data to sample file, right? Let's see what happens. Okay, T should be capital, right? Wonderful. Now you have a successful message. Refresh. What's the size? 80 bytes. Means it has been appended, right? Now, how do you verify the data? Cat command. HDFS DFS hyphen cat sample file or file 1? File. Now up to HDFS map reduce high scoop, then new file has been added, right? Same file will be appended and the block will be replicated with the same appending data on all the 3 data nodes or 1 node. Clear in it? Append to file. This is very, very important concept. Append to file. Now, earlier in high availability, we have discussed this Zookeeper. Now, few people are asking why we are doing installation, sir, most of the time. You have a ready-made Cloudera, a vendor. Now, on the day 1, if I ask to open the Cloudera and if I ask JPS and if I do the Hadoop commands, do you know what is JPS mean? What is the configuration files? No, right? So in order to understand Hadoop from scratch, we are first learning what Hadoop is and how to install Hadoop, right? Then Cloudera, on top of Cloudera, we can check the same commands. Now in the Cloudera, if you see, lot of services are there, Zookeeper and everything. In our local file system, we have only Hadoop. Now, if I want to install Zookeeper, how to install them? Remember, very, very important. From now onwards, we'll be installing the services manually. And we will check this in Cloudera as well. We'll check the resemblances. Now, I want to install Zookeeper. How we have installed Hadoop? Now you are free, I guess. You are listening, I guess. I have started already 15 minutes back. Okay. Now, what is the command to start the Hadoop? What is the command to download Hadoop? Hadoop download archive, right? Likewise, if I want to do any new service, Zookeeper download archive. Every service will have index of this Zookeeper. Click on this Zookeeper. Now you have all the services. Zookeeper 3, 4, 5, 3.4.5, 3.4.6 something. Now I can select anything. For example, if I have selected 3.4.6, size. What's the size of the Zookeeper? 17 MB. Right click. Copy link. What is the command to download? pwd sudo space wget, right click, paste, enter. Now your Zookeeper is downloading. How we have extracted Zookeeper? Hadoop. tar space hyphen xgdf, right? Likewise, we will be extracting this Zookeeper file, and then in the bash RC we will tell where Zookeeper is installed, where all the Zookeepers are. Zookeeper commands are stored. You're done. ls space hyphen ltr. Now you have a zookeeper 3.4.6. What is the command to extract? Sudo space star hyphen xzvf zookeeper tar.gunzip. Now your zookeeper is installed. For every CD, now what we have done? The ownerships, what is the ownerships it is showing here? Other different usernames, but what is the username? SD user. What's the group name? Hadoop. So we need to change this sudo space chown SD user Hadoop, and to which directory we are changing? Zookeeper. Enter ls space hyphen ltr. Now you have a zookeeper 3.4.6. You can rename, right? If I don't remember that 3.4.6, etc. What is the command to rename? Sudo space mv zookeeper to zookeeper. ls space hyphen ltr. Now you have a zookeeper service installed. cd zookeeper. Now for every service there will be a conf folder, right? Where all its services related information is stored. For Hadoop, it's a name node, core hyphen and everything. Now let us see what is there in zookeeper. Zoo underscore sample.config log4j configuration. Let us see what is there in zoo underscore sample.config. It is giving the port number. What is the port number of zookeeper? Write down. Zookeeper port number 2181. And these are all the commands where data node, where zookeeper is storing its directory temp zookeeper. So we are going with all this init limit, sync limit. I'll tell you what is this init limit and sync limit. Okay. Now you can keep this zoo underscore sample.config same, or else I'm just renaming sudo mv zoo underscore sample to zoo.cfg, zoo.config file. I have simply renamed this zoo underscore sample.config to zoo.cfg. Now I will open bash rc sudo nano. Why we are updating in the bash rc file? Tell me, guys. Yes, in order to tell this HD user Hadoop, because for HD user there is a bash rc, for Ubuntu user there is a bash rc. Now we are using this home HD user bash rc. Means for HD user we are telling, right? So we are telling this Hadoop, I am installing a new service. Hash means command. So I tell zookeeper installation path. Where is installed path? Export zookeeper underscore home, like export Hadoop underscore home. Where Hadoop is installed? User local Hadoop. So export zookeeper underscore home equals to, tell me, user local, not Hadoop, zookeeper, right? We have installed zookeeper in user local directory. Now, if you see here, export path equals to all the path where Hadoop / bin, user local Hadoop bin. So I can copy or else simply export path equals to $path colon dollar. What is that? Zookeeper underscore home is nothing but user local zookeeper / bin folder. Means whatever commands related to zookeeper, please go to this bin folder and execute. I'm telling. All the commands related to zookeeper are in this bin folder. And where is this bin folder? Zookeeper underscore home, user local zookeeper / bin. Control X, Y, enter. Source tilt / dot bash rc. Now cd space 2 dots ls space hyphen ltr There is a bin folder, right? cd bin ls space -ltr. Now what does this? These are all related to zookeeper commands. What is the first one? zk server.sh. So if I do dot zk server.sh start, what does it say? Zookeeper started. JPS. What is the new service you are seeing? Forum peer main. If you open Cloudera and give sudo JPS, you should see this forum peer main. If I directly show that forum peer main is Zookeeper means you will not understand. Now we have discussed about Zookeeper. We have explained how to install Zookeeper and what is the service and how to start Zookeeper manual. Now you can easily relate forum peer main means okay. In Ubuntu we have installed Zookeeper, so this service should be Zookeeper service. Clear and everybody? We'll be discussing about the G nodes and everything. You have started the DBS database commands, right? In like DML commands, DDL commands. Where you have practiced in SQL developer interface, right? Now, if I want to install MySQL on my machine, which is my machine Ubuntu, right? Ubuntu 20. How do I install? Because manual installations and how they are working, if you know, it will be very easy for you because any new service you will easily download and you can explore it. Okay. So now our intention is to install MySQL in our server. Why? Because in order to understand Scoop is importing the data from RDBMS to our HDFS. We need to have a MySQL, right? In our Cloudera also you have a MySQL. So first of all, we need to install MySQL. How to install? This is what is the Ubuntu version we have installed? lsb_release. You need to know all these commands. What is the version? 20.04. So we are now trying to install MySQL on this Ubuntu server. Go back to your Mozilla MySQL installation plus Ubuntu. What is the version? 20. Now here you see so many how to install MySQL on Ubuntu 20.04. First link. Just follow the same document. But before doing all this, concentrate on what we are doing. Okay. Down, down, down. So what is the prerequisite? First of all, sudo space apt update. The first command you need to do is any new service, it updates the package index of your server if you have not done so recently. Sudo space apt update. Just copy here, copy it, go to the terminal, right click, paste. I am taking sudo means for HD user I am giving root access. So sudo, enter. Wonderful. So update is done. Now what is the next command? apt install MySQL-server. Right click, paste. Now you are installing MySQL server. Oracle, MySQL, SQL, Postgres, DB2. These are all the servers where you store structured data. Right? Enter. Now it is downloading. Why? Enter. Now your MySQL server is installing on your Ubuntu because everything you are learning how the cluster is behaving on single node. Once we know this single node, then I will try to install Cloudera also so that you will know how single nodes are working. Cloudera multi-node is working. Then I will take your Cloudera and then I will tell all this. The basic practice should be on this single nodes only. The more you practice, the more you get confident and technically very strong, right? Because the same command Cloudera is doing, and you are doing the same command in Ubuntu, right? Once this is done, I'll give you some exercises to create DML commands and DDL commands. Please practice DML commands, DDL commands today. Tomorrow I'll be starting Scoop. Scoop is like ingesting the structured data into your HDFS. So once Scoop is completed tomorrow, we will start the very, very important topic, Hive. Hive is very, very important, okay? So please be attentive this coming 3 to 4 days. Now your hey. Why this is slow again? Internet connected only, right? Yeah, I have also tried in Amirpet, Hadoop. By birth, I didn't get Hadoop. Okay. Even also, I learned Hadoop from one of the trainer. So when I started my career, I used to 6 to 7 a.m. batch. I mean, we were sitting like 300 plus students. How many? 300 plus students. I was sitting somewhere. When the places come, I have to sit. It's not like reserved, right? Whoever comes, sit first like that. So like this, 300 members, the trainer used to say. Now out of those 300 members, I remember only 10 people got job. The trainer got the same material to everybody. Everybody 300 members paid the same amount. They have given the same time. But why we 10 members got the job, others are struggling. At that point, I helped few of them. So no matter where you sit, if you focus on what the trainer is saying, and if you practice what the subject is doing, can definitely in the race. That's what the main. Okay, understand that. MySQL install is running as process ID 8339. If you see MySQL, I created link, system link under lib system d system MySQL dot service. Wonderful. Your MySQL is installed now. Now, if you want to test the service, you can check the sudo system start. Okay, copy, right click, paste. Here, if you say it is saying that MySQL D is running, right? So just want to know, in place of start, just give status. What does this say? Active running. So MySQL started and everything. Now there is a secure installation for this MySQL. So simply follow the steps. Sudo space MySQL secure installation. Copy, right click, paste, enter. Give Y. Now it is asking, give the password. Please enter 0 for low, 1 for medium, 2 for strong. I'm just giving 1 because it is our own. Don't give your, your name at the rate 56, 78, 25 like that. Don't give those names. Simple. Okay, this is your own right. At the rate 65, 70, I have seen fewer people. They're giving very simple root 1, 2, 3, big data 1, 2, 3 give. Okay. Password, I'm just giving capital B, small, big data at the rate 1, 2, 3. New password, big data at the rate 1, 2, 3. Do you wish to continue with the password provided? Why? Yes. Remove anonymous users. Do all. Yes, yes, yes. Disallow root login. Yes. Remove database. Yes, because we are creating fresh databases, right? Why? All. Yes, 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 yes. Now, what is the command to log into your MySQL? Any idea? No idea, right? So the command is MySQL -u username. -u stands for user, not his user, root. Root -small p. What is the password we have given? Big data at the rate 1, 2, 3. So big data at the rate 1, 2, 3. Now you are getting an error. What is this? Root cannot access your local host. So we need to update the root user in MySQL. So come down to this page. Okay, creating a dedicated user now. What you do is copy this command, alter user Sammy. So files, open a text file, or else here go to your notepad. Go to your notepad, paste this command, Control V. Now here you see alter user. Here in place of Sammy, just give root at the rate localhost means your Ubuntu server. What is the password we have given? Big data at the rate 1, 2, 3. Big data at the rate 1, 2, 3. Control A, Control C. Go back to your, just type in the terminal sudo space MySQL. It will take you to the MySQL. Okay. Right click, paste. Alter user root identified by the password. Enter. Now give an exit. Now we can give MySQL -u root -p. What is the password now? Big data at the rate 1, 2, 3. Now it is a show space databases. What does it do? It will list the databases. What is the command to create a new database? Create database. For example, database name training. Now again, show databases. Training is there, right? If I want to create any new tables on one particular database, what is the command I should use? If I create table, it will go to the default database. So if I want to use database, right? So use training. So under this database, I will create my tables. Now show space tables. Nothing is there. What is the command to create a table? Create table. For example, student ID. Data type integer. You have a primary key, non-primary key, right? What is the difference between primary key and foreign key? Or what is the primary key basically? It will not allow duplicates, right? So student ID, I'm giving primary key. comma, student name, varchar of 10. Okay, these two lines I'm giving an student. What is the course? Again, varchar or varchar, you can say. You can turn Hadoop, close the bracket, semicolon, enter. Now show space tables. What is the table you have? Student. If you want to know the schema, what is the command? How the table is built? Describe student. Student ID, student name, student course, type, primary key and everything. Now if I want to insert the data, what is the command? Insert into, what's the table name? Student values. Student ID 100. Okay. Student name. What's the name? Moin, right? Rohan. So Rohan. Then Hadoop. Okay. It will give an exception. Now insert into Hadoop. One row. Again, if I give the same 100 means primary key, it will not take. Okay. So 3 records. Select star from student. 3 records. Likewise, you can insert any number of records. What you do for today is, please go through these 2 installations and then you type MySQL. This is one MySQL installation, and then MySQL. I'm pasting these links, okay, for your information. In the notepad so that you can verify. DigitalOcean, Control C. I'm pasting this link in notepad. In the recorded session, you can see, okay? Control V. And then this is DigitalOcean link. And then the next link is MySQL link I will be providing you. Open a new page. MySQL plus type NTU. MySQL plus NTU. Now here is it. MySQL by examples for beginners. So start exploring this page today to create tables, to brush up your knowledge on MySQL. For example, summary of MySQL commands. Drop database if exists. These are all database level. Table level commands. All this. So what I ask you to do is start from 2.1 till 2.8 do. 2.1, click on this 2.1, create database, Southwind, copy this command, Control C, go here, right click, paste, enter. You have a database created. Now go back here, drop database, Control C, right click, paste, enter, drop database. So all commands should work for you. Control C. I'm just going to the notepad. So your assignment for today is what we have discussed from morning: yarn architecture, high availability, zookeeper installation, append to file, MySQL installation, few commands, right? So please go through this video, sit with your friends who are very interested to learn, and mutually work on this. right? So that is for today. Now, what are your doubts? Please come one by one. Okay. Thank you all. You can install. Don't install Oracle because we are doing MySQL right on the Ubuntu. Scoop uses MySQL. Don't do Oracle and everything because it requires more RAM and space for you.